Hello everyone, welcome back to the channel The Host Code. So today we are going to solve a problem daily LeetCode challenge step by step in Java. So today's problem is maximum number of events that can be attended. So this is a fantastic greedy algorithm problem that teaches us about optimal scheduling and priority queues. So whether you are preparing for coding interviews or just uh, any other reason to sharpen your problem solving skills, the problem has some really interesting insights to offer. So let's start with the problem statement. I hope you have read all this problem statement. So I'll be explaining this problem on the notepad right now. Okay, so let's read the problem statement first. So in here they have given that your problem is you're given an array of events. Okay, array events. Every event is I starts at day I and ends at end day I. Okay, you can attend an event I at day D where start time is less than equal to D and less than equal to end time I. So you can only attend one event per day and return the maximum number of events you can attend, right? So this is the example. As we read the example here, okay. So so it starts at 1 and ends at 2, and it starts at 2 and ends at 3, so starts at 3 and ends at 4. So we can return all the events, like all the 3 events. So these are the maximum events we can attend. So this is pretty simple. So let's see the constraints. The constraints are 1 less than equal to events dot length and less than equal to 10 to the power 5. Okay. So the key insight here is that we want to maximize the number of events we can attend, and we need to make an optimal choices about which event to attend on which days, right? So this is the approach we need to follow. Like, this is the insight we get from this question and the problem or the problem statement. So let's discuss a deep approach, a brute force approach and an optimized approach in the notepad. So let's start discussing the brute force approach first. Okay. The brute force approach would be to be try all the possible combinations of events and see which combination gives us the maximum number of events we can attend, right? So the algorithm starts with oh, the algorithm starts with first step, like first we need to generate all the possible subsets of the every event, right? So that we can see. So first step would be generate all the possible subset of events, right? And what could be the second step? So we have generated all the subsets, right? For each subset we need to check. For each subset we need to check if it is valid. Is it valid or not? Is it valid subset? What do you mean by valid? No two events on the same day, right? No two events on the same day. So that's how we check that it is a valid subset or not. So next, the third point would be return the size of the largest valid subset. Return the size of the largest subset, right? So what could be the time complexity for this? As we say that brute force approach has most of the a very large time complexity and space complexity. What could be the time complexity? Sorry. What could be the time complexity? So if we see, like, we might be having possible subsets, right? These possible subsets could be 2 to the power n. So we have 2 to the power n possible subsets, right? And for each subset we need to check. For each subset we need to check. We need to validate it, right? So for that, the complexity would be how many days the subset is, right? So the time complexity would be of 2 to the power n and into m. 2 to the power n into m, right? Into max days. It's a lot. So what could be the optimal approach if we talk about? Okay, let's see what could be the space complexity. What could be the space complexity now? So what could be the space complexity? So this approach is clearly too slow for the given constraints, where n can be up to 10 to the power 5, right? So O of n, because this approach is clearly too slow for the given constraints, where n can be 10 to the power 5, up to 10 to the power 5. So the space complexity would be O of n, right? So what could be the optimal approach? Let's discuss the optimal approach right now. Okay, let's discuss the optimal approach. What is so the optimal approach could be using greedy with priority queue. Right? So the key insight is that we should use greedy approach. For each day, we should attend the event that ends earliest among all the available events, right? So I repeat again. So for each day, we should attend the event that ends earliest among all available events, right? So this is because attending an event that ends later gives us more flexibility for future days, right? So why does this greedy with priority queue approach works? So why does this greedy and priority queue approach works? So if we have multiple events available one day, if multiple events available on one day, choosing the one that ends earliest doesn't reduce our future options, right? So choose the one that ends earliest doesn't reduce our future options, right? So is this the only thing? So there's another thing. Events that end later potentially be attended on later days, right? So think about this approach. If I say, like, first point was, if we have multiple events available one day, choosing the one that ends earliest, once that ends earliest doesn't reduce our future options, and the events that end later can potentially be attended on later days, right? Events that end later can be attended on later days, right? And what could be the next point? The greedy choice leads to an optimal solution, right? Like, if you have solved any greedy problems before, you might have observed that the greedy choices leads to an optimal solution every time. So priority queue handles all these first 2 points, and the greedy approach leads to an optimal solution every time. So greedy leads to optimal solution, right? So let's check what could be the pseudocode for this question. Let's get into the pseudocode. Okay, so let me draw a line here. So how could be the algorithm first? Like what could be the algorithm for this greedy with priority queue approach? So first we need to sort the days. First we will be sorting the days, right? So sort the days, and then what could be the next? So why are we using priority queue over here? So priority queue, if we use a priority queue to keep track of the end days of available events, right? So we use priority queue to keep track of the end days of available events. Use priority queue to keep track of the available events, right? So this is our second point. So we have got all the end days, we have made our priority queue, we tracked all the end days in the priority queue, we have sorted. After that we have made the track of priority queue in the priority queue. So what to do now? So for each day from 1 to the maximum possible day, from 1 to the maximum possible day, we will run a loop and add all the events that start on this day to the priority queue. From starting from the 1, we will add all the event that starts on this day, to the priority queue. We are keeping track of the starting days, right, to the priority queue. And next, what we'll be doing? We will be removing the events that have already ended. We need to remove the events, right? Remove the events that have already ended, right? And then if there are any any available events, attend the one that ends earliest. Attend the one that ends earliest. Okay, how could we get it? On the top of Min-Heap, right? So this will be our approach. And what could be the time complexity of this approach? So if we talk about the time complexity of this approach, so sorting would take at the first stage we are sorting the array, so sorting would take some time. So n log n for sorting events, and we need to see how many days, like depends on the days. After that it depends on the days, like if O of D depending on the days, for iterating through days where D is maximum number of end days, right? So O of T, maximum number of days, right? So each event is added and removed from the heap at once. So each event is added and removed from the heap, right? So it is n log n. So what could be the total time complexity of this? Order of n log n plus t, which is maximum days. It depends on the days. Or if you say d, we can say n also. Like we can say n also. So let's get into the pseudocode first. Like let's try to write the pseudocode. Okay. So as we said, like we need to sort first. So let's write. We get an array. This is a max events. We get an array, right? So we need to sort it. First we would be sorting it. Sort events by start day, right? Sorry. Sort event by start day, and next initialize the priority queue. Min-Heap. Just take a note, like Min-Heap for end days. Okay. So next step would be initialize an index at 0 and max events to 0, and then we'll start the loop. No, we'll not start the loop. We need to ensure how many max days. We need to find the max days, right? First we need to find the max days. Find max days, maximum end day among all events. And then what would be doing? We would be looping, traversing over the max day equals to 1 to max day, add all events as discussed over here, add all events, right? Add all events while when we'll be adding the events, right? We need to make sure while event.index is less than event length and event index 0, like first one, like the start day, which means start day, 0 means start day, equals to day, right? So equals to start day, and next we will be adding the event. Add the event index equals to event index to priority queue. Sorry, we need to add the event index to priority queue and increment the event index. Increment event index, right? So then what we'll be doing, next step would be if what we have done before, like remove all the events, right? So right, this is not the approach. So okay, so we need to remove events that have already ended, right? Before after adding the events, you need to remove the events which are already ended. So for that we need to check the end day. So removing while the priority is queue is not empty, right? And top element, we will be choosing the top element from the min heap should be less than the day, right? So that we can remove it. So remove it, right? So and then remove top element from priority queue, right? And then the next step would be, as we discussed over here, we would be attend one event if available, attending that event if available, right? So if priority queue is not empty, and if it is not empty, what we'll be doing? Remove the top element from the priority queue and increment the max events. Remove the top element and increase the max events, right? Is it? We'll be doing this. So, and then our next step would be return max events. Yeah, we are done with this. Return max events. So return max event. Let's just walk through an example. So let's take an event, right? Let's take an event. So that would be 1, 2, 2, 3, 4, right? So this is our example. So day 1 the event would be add. We will be adding the event. We will be adding this event to the heap. 2, we will be adding this, the end day, as we have discussed in the pseudocode. We will be adding the end day to the heap and attend every ending. And then what we'll be doing? Attend event ending on day 2, right? Oh shit. Event ending on day 2, right? The result would be, the max events would be increased to 1, and then it will be increased to 2, it will be increased to 3. So the max event would be 3, right? So just start coding this question, right? So let's code this question. So first we, as we discussed, we need to sort the array. Arrays.sort, right? Events, what to sort? We need to sort the events array. So how we need to sort it? It is in lambda expression. So we'll be sorting based on the start day. Based on the start day, comma b comma 0. Starting based on the sorting based on the start day. And next, what we'll be doing? We will be initializing priority queue. Priority queue as an integer. We will be storing integer, like we will be storing the end days like a min-heap, right? End days as a min-heap. Integer, let's say pq, new priority queue queue. Okay, we have initialized it, and then as we discussed in the pseudocode, we'll be initializing two variables. It is an event index, which is equals to 0, right, which is equals to 0, and also we will be initializing max event, so that we will be returning how many events that we have attended. We can be at maximum events that we have attended, we can attend through the array which we have given, right? So we have initialized this, and next we need to find maximum day we need to consider, right? What are the maximum days that we need to consider? So for that, we need to initialize a variable called max day to 0, and let's just traverse through a loop. This is for each loop which we have coded before. You might be knowing how for each loop works, right? So this is for each loop. Max days, max day equals to math.max. Just use the inbuilt functions and your work would be getting easier. Max day and event.1. Why are we considering 1, right? We need 1. What is 1? It is the second index of the start day and end day. What is 1? 1 is considered as an end day in this array, right? So we are considering max days by end day. So we have got the end days. So we need to process the each day from one day to the max day. We have got the max days, right? So we need to process it from first day to the last day. So again we'll be running a for loop, like we consider it as a day. Let us consider it as a day starting from 1. So day shall be less than or equal to max day, right? Max day. Okay. So and day plus day shall be increasing with 1. And then what was our next step? Like as we discussed in the pseudocode, we shall add all the events starting on this day. What are the events starting on this day? So while event index, we have initialized it before, as you remember, as event index is less than event length, events dot length, it shall and events events event index, events or event, yeah, it is event index 0. What is 0? It is a start day. It is a start day. We are saying what are the days starting on this exact day. What are the events starting on this exact day by the start day. So if there are any events starting on this day, we will be adding it to the priority queue. So offer events, events event index 1. What is this? The end day. We are adding the end day, right? So event index would be increasing with 1, right? So event index would be increasing with 1. Let us so after adding the index, after adding the start days, all the events starting on this day, What we need to do next? What was our next step? We need to remove the events that we have already ended, right? So for removing the events, while the queue is not empty, we need to check if the queue is not empty. Is empty. If the queue is not empty, and sorry, and what we need to do? We need to check the top index. We need to peek and see if the peak value is the top value is less than the day. If yes, then we need to remove it. Dot poll. Right? After removing the index, what was our next step which we have discussed in the pseudocode? What was our approach after this? So after this, we would be attending an event if available. If there is any event available, we need to attend that event, right? So that we need to increase the max events. So we will be attending an event. How? When we'll be attending an event? If the queue is not empty, means we have any event to attend. If the queue is not empty, we can attend the event. Okay, so attending an event means we have attended this event, so we need to remove that event from the priority queue. So we have removed it, and we need to increase the max events, right? We need to increase the max events. Okay, so then return the max events. So let's check what we are doing. We are sorting the array based on the start index, and we are initializing priority queue, and then we are initializing this event index and the max events. We are finding out what is the max day and starting a loop from first day to the max day. In this process, we are checking if the event ends in the first day. Add all the event starts on the first day, add all the events to the start on this day, and remove the events that have already ended, and then attend event if possible. So let's try to run this program and see whether if it gives an output. So okay, so here we are getting an error. So what we have missed over here? Sorry, my bad. So we need to minus it. And event dot length. Sorry. LENGT. And then done. Okay. Event or events. It is events. Sorry, EVENTs. Yeah. Events and index 0. Event index 0. Yeah. Okay, let's run this. My bad. Keyboard problem, I guess. Yeah, it's running. So let's try to submit this question. Okay, so what are the key points in this code which we have discussed? So we sort the events by start date to process them in the chronological order, and priority queue, we have used priority queue. We use a Min-Heap to always get the events with the earliest end day. And event addition, like we are adding the event every day. We add events to the Min-Heap with their start day arrives when the start day arrives, and we remove the expired events, those that are ended before the current day, right? And the greedy choice is like we always choose the events that ends earliest over here. So the time complexity would be n log n, where n number of events and d is the maximum of n space end day, and space complexity would be O of n in the priority queue. So and that's all. If there is any interview tips to be given, always start by explaining the brute force approach. Like whenever you attend any interview, it would be a spotlight for you if you start with the brute force approach and identify why greedy works over here, and the key insights about this: choosing events that end earliest. Consider edge cases like events that start and end on the same day, right? And this problem is beautifully demonstrates like how greedy algorithm can lead to optimal solutions when we make the right local choices, right? And if this video helped you understand the problem better, please give the thumbs up. Don't forget to subscribe to the host code for daily lead code question solutions, and hit the bell icon to get notified when I upload the new content. what a, what problem would you like to see next? Like if you have any suggestions, like drop your suggestions in the comments below. Thanks for watching, and I'll see you in the next video. Happy coding.